Hi everyone, so now we're going to be learning about how to multiply rational functions. And once again, because rational functions are fractions by nature, when we multiply them like we multiply fractions. And if you remember, when we multiply fractions, you just multiply the tops and the tops and the bottoms and the bottoms. Now this one I'm going to make a little bit more confusing only because we're going to try and simplify a little bit first before we multiply. That makes it a little bit easier to multiply because the numbers don't get as big. So for this first example, we have 3 over 9x to the fourth times 6x over 4x squared. I'm going to start by simplifying that left fraction, which is 3 over 9x to the fourth. If you notice, you have a 3 on top and a 9 on bottom. Both of those are divisible by 3. So I'm going to divide them both by 3. 3 divided by 3 gives me a 1. 9 divided by 3 gives me 3. So I can rewrite this fraction as 1 over 3x to the fourth. Now, on the right fraction, I noticed that the numbers, the coefficients, 6 and 4 are both even, which means I can divide them both by 2. So if I divide them both by 2, 6 divided by 2 gives me 3, 4 divided by 2 gives me 2. So that's what I have there. That's great. Now let's look at the x's. We have an x on top and 2 x's on bottom, which means I can take 1 x out of the top and 1 x out of the bottom. So the top just stays 3, and the bottom, you take 1 x out and you're left with just an x. So this is as simple as they'll go for right now. And so now which makes it easier to multiply because now on the top I'm just multiplying 1 and 3. So 1 times 3 gives me 3. And then on the bottom we have 3x to the fourth times 2x. So first I'm going to multiply the coefficients. 3 times 2 gives me 6. And then x to the fourth times x. When we're multiplying variables like this, you add the exponents. So I've got x to the fourth times x to the first would give me x to the fifth because 4 plus 1 is 5. All right, so 3 over x over 6x to the fifth. The last thing I can do is I can actually simplify this a little bit more because I have a 3 on top and a 6 on bottom. Those are both divisible by 3, which means 3 divided by 3 gives me 1, and 6 divided by 3 gives me 2. And then I'm just left over with that x to the fifth. This is my final answer, 1 over 2x to the fifth. All right, let's look at the second example. On this second example, this is in what we call factored form because everything's in those parentheses. And so when we multiply, like I told you, you just multiply the tops, bottoms, and bottoms. So really, potentially, I could just kind of like draw this big old line and say that these are all multiplied. Now, the reason why I do that is because remember on the last couple of videos we've talked about what if something happens on top and happens on bottom, we can cancel it out. So if you look, we have a 3x on top and a 3x on bottom. Okay, those cancel out. That's great. That makes it a little bit easier. And then I have an x minus 2 on top and on bottom. Now the x minus 2's came from the separate fractions, but that doesn't matter because we're multiplying them, so it all ends up in one fraction anyway. So this x minus 2 will cancel out with this x minus 2. And now what I'm left over with is 10x over x minus 5. And this is my final answer. I can't simplify that at all. And so that was pretty easy. So when it's in factored form like that, it makes it really easy. We just cancel out what happens on top and on bottom. All right, let's look at the third example. The third example is x squared plus 8x plus 7 over x minus 7 times 3x over 3x squared plus 3x. So like in that second example, what we want to do is get it to be in factored form, and then we can just write a big old fraction and cancel out what we need to. So I'm going to start with the top left part, which is a quadratic trinomial. So I'm going to use the box method. We have x squared in the top, 7 in the bottom. We want to multiply to be 7 and add to be 8. Oh, sorry, I said add to be 8. So there's only one thing that multiplies to be 7, 7 times 1. And good news, 7 plus 1 is 8. So we can just use 7x and 1x. What do the bottom two boxes have in common? 1. Top two boxes have an x. Left two boxes have an x, and right two boxes have a 7. So I can rewrite the top of that as x plus 1, x plus 7. And then on the bottom we have x minus 7 times 3x over. Now, the bottom of the right fraction, notice that they both have 3's in common and they both have x's in common. So even though I can't use the box method on this one, I can factor it still by just taking out what's common. So they both have a 3x in common. I'm going to write 3x right there. And then if I take a 3x out of the front one, I'm just left with x. If I take a 3x out of the back one, that's all that there is. So because I'm dividing it, I end up with a 1. So if I take out a whole thing, like I'm taking out 3x, and obviously this part is 3x, I still have to represent that there was something there at one point, so I have to put a 1 there. Okay, so now it's in factored form. So I'm just going to write it as a big fraction by just combining these two lines. And then we're going to cancel out what happens on top and on bottom. The first thing I notice is that you have a 3x and a 3x, so those cancel out. Then they're coming from separate fractions, but it's okay. You've got an x plus 1 and an x plus 1. So what's left over is we have an x plus 7 on top and an x minus 7 on bottom. And that is your final answer. Unfortunately, even though they look really similar, you can't simplify those because one has a plus and one has a minus. And so that is our final answer. All right, last example, and of course it's maybe the hardest example. We have x squared plus 10x plus 9 over x squared plus x minus 72 times x squared minus 14x plus 48 over x minus 6. Now, 3 out of the 4 chunks are quadratic trinomials, so we're going to have to do 3 box methods. I'm going to start, in fact, I'm going to just use different colors to represent them so that we don't get confused. I'm going to do red, blue, and let's do green for over here. We're going to do the box methods for all of them first, and then I'll rewrite everything. So for the red one, we have x squared plus 10x plus 9. So we have an x squared and then a 9. We want to multiply to be 9 and add to be 10. So we know that it's 9 times 1 or 3 times 3. The only thing that will add to be 10 is the 9 and 1, because 9 times 1 is 9 and 9 plus 1 is 10. So I'm going to put a 9x up here, 1x down here. What do the bottom 2 boxes have in common? They don't really have anything in common, so we put a 1. What do the top 2 boxes have in common? They have an x in common. The left 2 boxes have an x in common, and then the right 2 boxes have a 9 in common. So those are our factors. I'm just going to leave that like that for a minute. So in fact, well, let me write the factors. We'll say x plus 1, x plus 9. Okay, now let's go to the blue, which is the bottom of the left one. I'm going to just do that. Well, I'll do it on the bottom so we can kind of keep them on the same order. Okay, so we have x squared and then a negative 72. We want to multiply to be negative 72 and add to be 1. So numbers that multiply to be 72, there's plenty of them, but I'm just going to tell you right now, it's going to be 8 times 9. Because if I can make the 8 a negative, then negative 8 times 9 is negative 72. And negative 8 plus 9 gives you a positive 1. And so I'm going to put a negative 8x in one of the boxes and 9x in the other box. What do the bottom 2 boxes have in common, or what can I divide them by? 9. The top 2 boxes have an x in common. The left 2 boxes have an x in common, and the right 2 boxes have a negative 8 in common because they're both negative. So the factors are x plus 9, x minus 8. All right, now let's go to the green one and do the box for that guy. So we have x squared and 48. We want to multiply to be 48 and add to be negative 14. So let's think about the things that multiply to be 48. We have 1 and 48, 2 and 24, 4 and 12, 6 and 8. And I'm going to, so out of all of those, which ones will add to be negative 14? The 6 and the 8. But because we want it to be add to be negative 14, both of them have to be negative. Because negative 6 times negative 8, or negative times a negative is a positive. So negative 6 times negative 8 would give you positive 48. And then negative 6 plus 8 gives you negative 14. So I'm going to put a negative 8 in one of the boxes and negative 6 in another box. What do the bottom 2 boxes have in common? Oh, sorry, that should have an X. What do the bottom 2 boxes have in common? They have a negative 6 in common. The top 2 boxes have an X. The left 2 boxes have an X, and the right 2 boxes have a negative 8. So my factors are X minus 6, x minus 8. Okay, that was a lot of box method, but now we can write out the new equation like this. So the top of the left will end up being x plus 1, x plus 9. Then the bottom will be x plus 9, x minus 8, times the top of the right fraction will be x minus 6, x minus 8. And then the bottom of the right fraction, we didn't have to factor, it just ended up being that x minus 6. We can't do anything with that to simplify it, so we just leave it as x minus 6. All right, so we're going to just make this a big fraction, and then we're going to cancel out what we see in common. So there's a couple of things in common, but the first thing I notice is that there's x minus 6's, and then we have x minus 8's, and x plus 9's. And literally everything got canceled out except for the x plus 1, so my final answer is x plus 1. And that's crazy because we ended up, like, x plus 1 came from this big thing, and so obviously simplifying really does help. And that's how we multiply rational functions.